In this video, I'm going to talk about simplifying radicals. We're going to do some square roots, cube roots, and fourth roots with and without variables. Okay, so let's look at our first problem. We have 5 times the square root of 150. So the first thing that I'm always going to check is to see if the radicand is a perfect. So in this case, a perfect square. So if you'll look at your list, if you'll reference your list, you'll see that 150 does not appear. So that means we're going to have to break it down into the product of a perfect square and something else. So you can use your calculator. So you can do 150. Now usually if it ends in a 0 or a 5, I'm going to start with 25. And you see that you get 6. Now 6 is not a perfect square and it does not contain a perfect square. So I feel relatively confident that that is the largest one we're going to have. So we have 25 times 6. So 25 is going to come out because it's a perfect square, and 6 has to stay under that radical. So we have 5 times, now the square root of 25 is 5, times the square root of 6. So the last thing that we have to do is multiply to get our final answer. So we have 25 square root of 6. So in this problem, we're still dealing with a square root. So again, 63, not a perfect square, not in our list. So we'll go back to the calculator. And we can do 63. We can start small, divided by 4. Not evenly divisible by 4. Now I know that it's divisible by 9. So we can try 9. And 7 is a prime number and is not a perfect square. So I know that's the largest one that I can possibly have. So I have 9 times 7. So 9 is going to come out, 7 has to stay, so I have negative 8 times the square root of 9 is 3, square root of 7, and negative 8 times 3 is negative 24 square root of 7. So now please take notice that we've moved into a cube root, so we need to be looking at our cube root list. Okay, so on your cube root list, you would need to see if 875 is a perfect cube. And it's not on the list. You can also check here in your calculator, go right here to math, and you get this menu. You can see number 4 is a cube root. So 4, and we can do 875, and it's not a perfect cube. Okay, so we need to figure out what perfect cube is in 875. So again, if it ends in that 5, I'm likely going to try the 125 first. So I have 875 divided by 125. And that again gives me that prime 7, so I know I have the largest perfect square. So that gives me the cube root of 125 times 7. So this is going to come out and that has to stay in. So the cube root of 125 is 5 times the cube root of 7. So again, we're in cube root, so 2 times the cube root. Now 54 is not a perfect cube, so I need to figure out what perfect cube is in 54. So it's not a very large number. So we can try 8. Doesn't work. So we can try 27 divided by 27 is 2. 2, nice. Small number, definitely not a perfect square, doesn't contain a perfect square, so I know I have the largest. So remember that negative has to be attached to what's coming out. So I have negative 27 times 2. So I have 2 times the cube root of 27 is negative 3. Cube root of 2. So we're going to multiply. We get negative 6 cube root of 2. So now notice we've moved into fourth root, so we're looking at our fourth root list. So I have negative 3. The first thing I'm going to check is 567 a perfect fourth, and it's not. Okay, so I'm going to go through, I'm going to say 567 divided by, let's try 81. And again, we get that nice little 7. So we have 81 times 7. So I have negative 3 times the fourth root of 81 is 3 times the fourth root of 7. So I have negative 3 times 3 is negative 9. Fourth root of 7. So again, a fourth root. First thing I'm going to do is check my list to see if 405 is a perfect fourth, and it's not. So if it ends in 5, I might check the 5, but that 625 is larger than 405. So let's do 405 divided by, let's try 81. And that's it. 5 is not a perfect square and doesn't contain a perfect square. Lets me know 81 is the largest. So I have 81 times 5. So I have 6 times the fourth root of 81 is 3 times the fourth root of 5. So we have 18 fourth roots of 5. That's my final answer. So we are back to a square root, but notice we've added a variable. So I'm going to do 3 times the square root. So the first thing I would check is to see if 252 is in my list, and it's not in my list, so it's not a perfect square. So if it ends in 2, oftentimes I'll try 4, and then I'll try 16, 36, so on and so forth. Those are the easiest ones to get that 2 in the end, so I'm going to divide by 4. So it is divisible by 4, but notice that 63 still has a perfect square within it. It's divided by 9. So if it's divisible by 4 and is divisible by 9, it's divisible by the product of 4 and 9. So that means 252 is divisible by 36. So we get that nice prime 7 again. So I know that 36 is the largest. So I have 36 times 7. Now, k to the 5th, remember that the power, the exponent, has to be divisible by the index for it to be a perfect, and it's not. But I can do to k to the 5th exactly what I did to 252 and write it as the product of two things, one being a perfect and one not. So remember that what we're looking for here is the power that is less than 5, but is the largest number less than 5 that is divisible evenly by 2, and in this case is 4. Okay, so we have 3, so this is coming out, staying in, coming out, staying in. Okay, so I have 3 times the square root of 36 is 6 times the square root of k to the 4th is k squared. So remember, we take the power and divide it by the index. That's our shortcut. 4 divided by 2 is 2, because there are 2 perfect squares, perfect k squares in k to the 4th, and then we have the radical 7k. So to finish our problem out, we need to multiply. 3 times 6 is 18, k squared, square root of 7k. So we still have a square root here, so I'm going to check, is 60 a perfect square? Now we know it's not, so I have 4 times. So I'm going to see what perfect square is in 60. So I'm going to do 60. I know it's divisible by 4 maybe. 4 and 15. So 15, the only factors of 15 are 1 and 15 and 3 and 5. None of those are perfect squares. So I know I have the largest. So I have 4 times 15. So a to the 6, 6 is evenly divisible by 2, so I can leave it as a perfect. And then I'm going to leave b. Now notice we're leaving both of those, but for very different reasons. A to the 6th is already a perfect square, and b has an exponent of 1, which is less than my root, which means I can't do anything with it. It's not going to come out. So I have 15, a to the 6th is coming out, and b is staying in. So I have 4 times the square root of 4 is 2. The square root of a to the 6th is a to the 3rd. Remember, 6 divided by 2. The square root of, the square root of 15b. So we need to multiply to simplify. So we have 8a cubed times the square root of 15b. So we're still doing square root. So I have 3 times the square root. Now I don't have to do anything with 49 because it is a perfect square. 9 is not evenly divisible by 2. So the largest number less than 9 that's evenly divisible by 2 is x to the 8th. Product rule says I need one more x to get back to x to the 9th. And I can leave y to the 16th because 16 is divisible by 2. So coming out, staying in, coming out. So I have 3 times the square root of 49 is 7. The square root of x to the 8th is x to the 4th, 8 divided by 2. And 16 divided by 2 will yield y to the 8th square root of x. So I need to simplify. 3 times 7 is 21. X to the 4th, y to the 8th, square root of x. And that's my final answer. So now we've moved to cube root, so make sure you're paying attention to that. So now I'm looking at a different list. Is 192 a perfect cube? And it is not. It's not in our list. So we can go to our calculator. So we do 192. Again, ends in 2. I'm going to try 64. Oh, divided by 64. And it is divisible and leaves me with a prime 3. So I know that's the largest that I could have gotten. So 64 times 3. Now, is 7 evenly divisible by 3? It's not, but I can write this as p to the 6 times p. And 18 is evenly divisible, so I'm going to leave it just the way it is. So this is coming out, staying in, out. So I have 2 times the cube root of 64 is 4. The cube root of p to the 6, 6 divided by 3 is p squared. And 18 divided by 3 is going to yield q to the 6th. And trapped in my radical still is 3p. So I need to multiply. So 4 times 2 is 8. P squared, q to the 6th, cube root of 3p. All one big term. Okay? So again, we have no number this time. Doesn't change the process. So I have the cube root. 14 is not evenly divisible by 3, but I can write it as a perfect. So I have negative r because that's what I want to come out. The largest number less than 14 divisible by 3 is 12 times r squared. 12 plus 2 is 14. And I can leave s to the 9th because 9 is divisible by 3. So that's coming out, staying in, coming out. So 12 divided by 3 is going to give me negative r to the 4th. 9 divided by 3 is going to give me s to the 3rd. And I'm going to be left with the cube root of r squared. So again, cube root. So I have the cube root. So the first thing I'm going to check is 625. Is it a perfect square? And it's not. But because it ends in that 5, I'm going to try 125 first. And it is divisible. Gives me a nice prime 5. So I know that I've gotten the largest, so I'm going to do negative 125. Again, that negative needs to be attached to our perfect so that I can bring it out. So I have 125 times 5. 28 is not evenly divisible by 3, so I can write this as m to the 27 times m. 27 divided by 3 is 9. And I can leave n to the 12th because 12 is divisible by 3. So this is coming out, staying in, out. So the cube root of 125 is negative 5. The cube root of m to the 27th is m to the 9th. And the cube root of n to the 12th is n to the 4th. And still under my radical is a 5m. Okay. So now we've moved to the 4th root, so we should be looking at a different list on our paper. So on your reference sheet, 243 does not appear as a perfect cube, perfect 4th. So we're going to go to our calculator. We'll do 243 divided by 16. No, 243 divided by 81. Is divisible by 81, and 3 is a nice prime number. So I know I've gotten the largest. So I have 81 times 3. M to the 5th can be rewritten as m to the 4th times m. 13 is not evenly divisible by 4, but 12 is. So I can rewrite that as a perfect. So we have out, in, out, in, out, in. So I have the fourth root of 81 is 3. The fourth root of m to the fourth is m. And the fourth root of n to the 12th is n to the third. 12 divided by 4 is 3. And still trapped in my radical is that 3mn. Okay. Okay, so we have a negative 2, still doing a fourth root. 80 is not in my perfect fourths. So we can go to the calculator. I'm going to start small, smallest one we have, and it is divisible. The next one is 81, so it can't be 81. So we have 16 times 5. 8 is divisible by 4, so I can leave x to the 8th. Now, y to the 9th, not divisible, but I can write it as y to the 8th times y, and I'm going to leave z. It's less than 4, has an exponent less than 4, so there's nothing I can do. So out, in, out, in. So I have negative 2 times the fourth root of 16 is 2, times the fourth root of x to the 8th is x squared. The fourth root of x to the 8th is y squared. So remember, 8 divided by 4 is 2. 8 divided by 4 is 2. And then I have the fourth root of 5yc. Okay? So we have to multiply to make sure that we simplify all the way. So negative 2 times 2 is negative 4x squared, y squared, times the fourth root of 5yc. Okay? Last problem, still a fourth root, so we're going to do 5 times the fourth root. 112 is not in our list, so we'll go to the calculator. We'll do 112 divided by 16, 7, so nice prime number 7, so I know I have the largest. So I have 16 times 7. 24 is evenly divisible by 4, so it's going to be c to the 24th. Can leave it. D to the 13th, however, not evenly divisible, so I'm going to change it to d to the 12th times d. So 12 plus 1 is 13. So this is coming out, in, out, in. So all of my things that are coming out are my perfect fourths. So I have 5 times the fourth root of 16 is 2, times the fourth root of c to the 24th, so 24 divided by 4 is c to the 6th, and d, 12 divided by 4 is 3, and still under my radical is my 7d. And we need to make sure that we multiply to get our simplest answer. 5 times 2 is 10, c to the 6th, d to the 3rd, times the fourth root of 7d. And that's our final answer.